Prove that the induced EMF in a synchronous generator lags flux by 90 degree. As per Faraday's second law of electromagnetic induction, induced EMF is equal to minus n d phi by dt is equals to minus n d phi m sin omega t by dt is equals to minus n phi m cos omega t. Induced EMF is equals to minus n phi m sin 90 minus omega t is equals to n phi m omega t minus 90. Thus, induced EMF lags flux by 90 degree. Rotor mass is equal to 100 kg. Speed of rotor is equal to 3000 rpm. Balance quality grade required is equal to G 2.5. What is the maximum permissible residual unbalance as per ISO 1940? The unbalance left after balancing is called residual unbalance. The question is whether residual unbalance is acceptable. It is decided by the selected balance quality grade. G 2.5 is a high precision balance quality grade for rigid rotating machinery. It is better than grade G 6.3, which is commonly used. Let's go deep into the concept of unbalance. Actual residual unbalance is equal to M into R, where M is mass of unbalance and R is radius of unbalance. Let mass of unbalance is 100 gram. Unbalance is at a radius of 200 mm. Residual unbalance is equal to 100 into 200 is equal to 20,000 gram mm. When there is no unbalance, center of gravity of rotor coincides with the axis of rotation. When there is an unbalanced mass, center of gravity shifts towards unbalanced mass. Center of gravity has become off center. That is, it has become eccentric. Centricity is denoted by small e. Let rotor mass is capital M. Capital M into E is equal to small m into R, or E is equal to M into R divided by capital M. Centricity is very small. It is measured in microns and rotor weight is given in kg. Thus, unit of centricity is gram mm per kg. When rotor rotates, unbalanced mass and center of gravity rotates along with it. Grade G 2.5 means that linear velocity of center of gravity is 2.5 mm per second. V is equal to omega into E, where V linear velocity in mm per second, omega is angular velocity in radian per second, and E eccentricity. In general, if grade of balancing required is G, then G is equal to omega into E. G is equal to omega into M into R divided by capital M into 1000. G is equal to omega into permissible unbalance divided by capital M into 1000, or permissible unbalance is equal to G into M into 1000 divided by omega. Permissible unbalance is equal to G into capital M into 1000 divided by 2 pi n by 60, where n is speed in rpm, or permissible unbalance is equal to 9549 into G into M divided by capital N. In our example, permissible unbalance is equal to 9549 into 2.5 into 100 divided by 3000 is equal to 796 gram mm. Thus, to achieve grade G2.5 as per ISO 1940, permissible residual unbalance should not exceed 796 gram mm. How fan motor works? In a fan motor, there is a main winding and auxiliary winding. Main winding is also called running winding and auxiliary winding is also called starting winding. Let us disconnect auxiliary winding. When a single phase AC supply is given to main winding, pulsating flux is produced by it. As per double revolving field theory, the flux can be resolved into forward field and backward field. Torque speed curves due to these fields are shown. At point A, torque due to forward and backward field are equal. Net torque is zero and hence there is no rotation. Suppose the rotor is moved slightly and speed increases to B. Torque due to forward field is greater than that of negative field. Net torque is developed and rotor accelerates to full speed. Thus, single-phase induction motor as such is not self-starting. However, once it starts rotating, it keeps on rotating. That is, it requires some means of starting. The most common way to start the motor is by adding capacitor in series with the auxiliary winding. Centrifugal switch is normally closed switch. By adding capacitor in series with the auxiliary winding, current in auxiliary winding is ahead of current in main winding by approximately 90 degrees. Thus, two phases are created. These windings are displaced with respect to each other by 90 degrees. When a two-phase current flows in a two-phase winding, a rotating flux is produced. Rotor starts rotating in the direction of flux. When speed of rotor reaches about 75% of the rated speed, centrifugal switch opens and capacitor is disconnected. What is the purpose of lubrication in the bearings? The main purpose of lubrication is to prevent metal-to-metal contact and thus reducing friction and wear. It also prevents corrosion, it dissipates heat, and it reduces noise. Normally, rolling bearings are lubricated with grease and sleeve bearings are lubricated with oil. What are the constituents of solder? Soldering is used for making metal-to-metal contact where application temperature is less than 450 degrees centigrade. It uses surface diffusion for joining metals and parent metals do not melt. The main constituent of solder is tin and lead.